My name is Isa Pacheco, and I will be presenting my Crosswalk Guard for Team CEWI Cumber and explaining the circuitry and coding behind it. To start off with, we have the ultrasonic sensor. Then we have our Arduino Uno, which is right here. Then three LEDs, green, yellow, and red. So green is to indicate to go, yellow is to indicate to be very cautious to the pedestrian, and then red is to indicate don't go, stop. Here we have our piezo, which is essentially a speaker to talk to the pedestrians who may not be able to visually see those lights to let them know go, cautious, or stop. Next is the transistor, which is used to manage the current within the circuit. Then the push button is used for manual override. Now to explain the coding behind it. This first chunk is essentially explaining what components are connected where. Next is the input versus the output. Here, the void loop explains that pushing the button switches the system to active or override mode. Here, our if statement sends a short pulse to the ultrasonic sensor to measure distance. And here, this is a conversion that converts the time of flight signal from the ultrasonic sensor to the Arduino Uno, but it converts the time of flight signal to physical units, essentially, that the Arduino Uno can understand. Then our if statement here means that if a pedestrian or an object is detected within 100 centimeters, then the buzzer will turn on. But if there is no pedestrian or object detected within 100 centimeters, then the buzzer will turn off via the transistor. And then here is a slight delay to prevent the loop from moving too quickly. So I am going to go ahead and run the simulation for you. And there it is. The lights turned on and everything worked according to the description. Moving on, here is the other circuit that I created for the mechanical arms in the robot as described in deliverable 3. So essentially, before I explain the mechanics, first let me explain the components. So first, here's the photoresistor. Here is the Arduino Uno. Here's the resistor to manage current. And then here's the servo motor. For the code, this is the setup basically mentioning what components are connected where, just like the other coding before. And then here is the meat and potatoes. So, as I tried to explain earlier, um, the robot is supposed to have mechanical arms. So when the photoresistor um, detects light, as depicted here in this code right here, then the arm will go down and prevent pedestrians from crossing because it'll detect like headlights from cars. But if there is no light detected from the photoresistor, then the mechanical arm on the robot will go up, allowing pedestrians to cross. And that is depicted in the 90 and 0, hence 90 degrees or 0 degrees. And then once again, same delay as within the other code. So now I'm going to run the simulation and show you how it works. As you can see, the gear is shifted to the side, basically simulating the arm going up or down. So I'll run it for you one more time. And there it is. Some additional insight that I gathered while doing this project was it was a little difficult to figure out the proper resistance for each of these resistors. And then also it took me a while for figuring out how the wiring should go with the push button. That did give me a little bit of difficulty to figure out that I needed to put these wires in terminal 2A, and then the other wires needed to be in terminal 1B. Overall, this was a very educational assignment and I really learned a lot. So, thank you very much, and I hope that this description was helpful.